Changing simulation parameters in LDAR sim is relatively straightforward. Common parameters to be changed in the virtual world settings are shown here. For example, we might want to change the number of sites being sampled in the model. The maximum value available is 1000. To reach 1000, you have three options. You may manually type in 1000, you may use the up and down arrows to change the value, or you may use the slider. If at any point you would like to reset the default value for a parameter, simply press Reset Default. For this simulation, we will use the maximum number of sites, which is 1000. We will leave the natural repair delay, consider venting, the leak distribution parameters as they are. Leak production rate may be a value that you want to change depending on the environment you are working in. The most commonly used value for leak production rate is 0.0065. If you are working with data that suggests a particularly high or low leak production rate, you may change this. For this simulation, we will double the standard leak production rate to 0.013. We will leave the carbon price, natural gas price, and global warming potential to their defaults. LDAR Sim currently has three regions available for simulation: Alberta, Marcellus, and the Permian. For this simulation, we will use the Permian. You'll note that the infrastructure file and the weather file change in accordance with the selection. In this case, we can see that facility samples from the Permian are being used, and weather associated with the Permian is also being used. To save the changes to these parameters, press the Save button. The changes that you've made will be presented in this pop-up. Click Save to confirm these changes. We have now set the parameters for our virtual world and are ready to change the general simulation settings. In this case, we will change the number of simulations to 5, and we will leave the default start and end dates. We'll press Save to confirm these changes. For our reference LDAR program, we will use OGI. For our alternative program, we will use ptruck again, and press Add to confirm this alternative program. To make changes to a program or the technology being used, you may click on these pencil icons to change the parameters. For example, with the OGI, there is a repair delay. This is the amount of time that passes between the detection of the emission in the OGI survey and the repair taking place. For example, we may change this here to 10 from 14, pressing Confirm and Confirm again to make these changes. In the OGI, we have several parameters that we can make to the parameter changes that we can make to the method. Common changes that you may want to make are the cost, either per day or per site, and importantly, the sensor minimum detection limit. The sensor minimum detection limit is the smallest leak that will be able to be detected by this method. In this case, there is the default value of 0.0362. Depending on the data that you have available to you and the technology you are using, you may have good reason to change this. For this example, we will slightly increase the sensor MDL to 0.05. In the time between sites parameter, this is the amount of time that it takes to travel from one site to another. If you have reason to change this, you may. For example, if working in an environment where sites are relatively close together, you may want to decrease this value to be more representative of the environment in which you are working. We'll leave the value as 30 for now. Press Confirm to make these changes, and Confirm again. In the same way that changes were made to the OGI program and the OGI, one might make changes to the truck program. In this case, we'll make a change to the truck method. In this case, we'll say that the sensor MDL is 0.02 instead of 0.01, and we'll slightly decrease the time between sites to 20, and press confirm to make these changes. We have now made some changes from the defaults. To run the program, read the disclaimer, press yes, and press run. Wait for the program to execute, and we will now be able to compare the results of this program to results of the previous simulation. Now that this simulation is completed, we may compare and view the results of this simulation to the previous simulation. The first thing of note from this simulation is that the median emissions rate of the truck program and the OGI program have gone up slightly from the previous simulation. This is likely because of the change we made to the minimum detection limit of these two methods. An increase in the minimum detection limit will result in fewer emissions being detected and thus increasing the median emissions rate. Any changes to parameters will result in changes to outputs. Another important note with LDAR Sim is that the program is stochastic. What this means is that for each program run, even if you use the exact same input parameters, you will get slightly different results every time. These results are somewhat predictable, but not wholly predictable. Therefore, testing different parameters and different combinations of parameters may be important for your use case. We may again review the output figures here and see that, again, the truck program outperformed the OGI program in terms of daily emissions, but did so by looking at figure 3 at an increased cost. The truck program again shows similar results in terms of being more efficient in terms of dollars spent per ton of CO2 equivalent.